Keyed services allows you to add multiple implementations of the same service. In Program.cs, you register a keyed service for dependency injection by either using the add key singleton extension method, the add key scoped, or the add key transient. The difference between a keyed service is that you have to add a key when registering a service. This acts as a differentiator between the different services. So we've registered a keyed service here of category singleton service with a key of category singleton 1. The key is an object type, so it could be a string or it could be an integer. We're going to register the category singleton service again with another implementation. So to do that, we just change the key, and now we've got two separate implementations for it. You can also do it if you've got a separate service and an implementation. So here we're registering the product singleton service as the implementation for the iProduct singleton service. We've got the key of product singleton 1. We can go down here, we can register another implementation of product singleton service, but just give it a different key. There are more ways of adding keyed services. Before we show you that, remember to subscribe to the channel and hit a like for the video. And let me know in the YouTube comments how you use keyed services. Now let's have a look at some of the other ways of registering keyed services. One of the benefits of using the generic extension method is that you get an exception at compile time if you make a mistake. So if we were to change the service to iProduct scoped, because the product singleton service doesn't implement the iProduct scoped, we get the exception at compile time. One of the other ways is to specify the service type as a parameter. So we specified the category singleton service here. We've got our two implementations of category singleton 1 and 2. We can also do it if we've got a service and an implementation. We specify the service first, followed by the key, and then this implementation for each of them. The disadvantage with this is if we were to make a mistake, so we use the iProduct scope against the product singleton service, which doesn't implement it, it won't give us the exception until runtime. The other way is to use the implementation extension method, where we explicitly create the instance of our service. So we need to specify the service provider and the key in the func. We don't need the service provider for this because the category singleton service doesn't rely on any other services. If we have a look in the category scope service, this is reliant on a category singleton service, so we need to inject that. So we pass through the service provider, and we can use the getRequiredKeyed service extension method, and we pass in whichever key we want to use for the implementation. And it's a similar story if you've got a service and an implementation. So we don't need it for the product singleton service, but for the scope service, once again, if we have a look, it's reliant on the product singleton service when it's initialized. So we get the service provider and we call the getRequiredKeyed service. We specify the type of iProduct singleton service, and then we specify the key. You can download the code example for this tutorial by going to roundthecode.com/examples. There's also a link for it in the YouTube video description. Now that we've registered the keyed services, we can inject them. You can do it in controllers, Razor pages and views, as well as middleware. But first, we'll show you how to do it with minimal APIs. We've registered two iProduct singleton services with the same implementation. We've given this key of product singleton 1 and product singleton 2. We've also done the same for the product scoped and also for the product transient. We have a look at these services. All this is doing is that it's initializing the service. It's storing the UTC time as a property. It's doing exactly the same for the product scope service and the product transient service. To inject keyed services in minimal APIs, after you specified the root, you specify the service type and then a name for it. But before you do that, you have to specify the fromKeyedService attribute and specify the key name as to the instance that you wish to inject. What we're doing here, we're just outputting the UTC time for each of our instances. We're going to try and run it now and see what the output is. The time outputted is slightly different despite the fact that we're using the same implementation and the same service. So we can see that with singleton 1 and 2, scoped 1 and 2, and also transient 1 and 2. This is because they're using different instances. Web API controllers work slightly differently, as you inject the keyed service into the constructor's parameter and then store the reference to it in a private read-only field. In our Web API controller, we've set up private read-only fields for each of our services. So we've done it for singleton, scoped, and transient. To inject the services in the constructor's parameter, we specify the service type and the name for it, but before that we need to specify the from keyed service attribute and the key name for it. From there, we get the parameters reference and then we store it against the private read-only field. So we do it for the singleton, we also need to do it for the scoped as well, and finally for the transient. From there, we can use the fields to output the time in a similar experiment to the minimal APIs. Let's have a look at the output. The output is the same as the minimal APIs, where the singleton 1 and 2 have a slightly different time, same with the scoped 1 and 2, and also with the transient 1 and 2. You can also inject a keyed service into a Web API endpoint method. You specify the type and the name, but you have to remember to include the from keyed service and the key. From there, you can use that within that method. You can inject keyed services in Razor pages and views. However, there are some slight limitations as to how you can inject them. We're doing the same in the MVC controller, where we're storing private read-only fields. We're injecting each of the services in the constructor's parameter and then storing the references in the private read-only fields. Then in this endpoint, we're returning a view. We've created a new model and we're outputting the UTC time from each of the services to send to the view. At time of recording, we're unable to use the from keyed services attribute in a Razor page or view. To resolve a keyed service, we need to inject the IServiceProvider into the Razor view. Then we can either call the getRequiredKeyed service or the getKeyed service. The difference being is that the getKeyed service will return null if the service is not registered, whereas the getRequiredKeyed service will throw an exception. On the Razor view, we're outputting the dates from the services dependent on the instance from the controller and the Razor view. So it's outputting the same time for the controller and the view for singleton 1. It's also doing the same for singleton 2, but the time in singleton 2 is slightly different from singleton 1. It's a similar story for scoped 1 and 2, but with transient 1 and 2, the controller and the view have slightly different times. And the reason being is that with a transient service lifetime, every time it's injected, it creates a new instance for it. Middleware works slightly differently, where you can only inject singleton keyed service lifetime instances into the constructor's parameter. This is because middleware only has single instances for the lifetime of the application. But you can do it with scoped and transient keyed service lifetimes. We're injecting the singleton keyed service lifetime instances into the constructor's parameter and storing them as read-only fields. But if we want to use a scoped or transient service lifetime, we need to inject it into the invoke async method. We do it in a similar way. We specify the attribute, the service type, and the name for it. Then we can use it throughout the method. Keyed services can also be injected using primary constructors. This is where we inject the keyed service as part of the class declaration. So we're injecting this service in a similar way. We have to add the attribute, the type, and the name, and then we can use that instance throughout the class. Before keyed services was introduced in .NET 8, you could still add multiple implementations of the same service. This is how you did it. Here we're using the add singleton extension method to register multiple implementations of iCategory storage service. So we've got category computer storage service and category home and kitchen storage service. If we have a look at each of these classes, the category computer storage service is returning a types property with these category types. Whereas with the category home and kitchen storage service, it's outputting this category type of home and kitchen. In this Web API controller, if we were to inject the iCategory storage service into it, it would get the last registered implementation of it. If we have a look in Program.cs, that will be the category home and kitchen storage service. We'll demonstrate that in this Web API endpoint by getting the types property and outputting it to the response. As expected, it's outputting the home and kitchen category, and that must mean it's getting it from the category home and kitchen storage service, as that's the category type specified. To get each of the services, you can specify it in an IEnumerable and specify the service type as the generic type. We're going to demonstrate that by outputting each of the types to a list. And there we are, it's outputting the category types from the category computer storage service, and it's also outputting the category type from the home and kitchen. The alternative is to register both services as keyed services. That way we can inject services with a key, which makes it more readable. To do that, you replace the add singleton extension method with add key singleton. We also need to specify the key, so we're going to specify this one with computers, and for this one we're going to specify it as home and kitchen. Incidentally, you can also use the try add key singleton or scoped or transient extension methods, and what that will do is if the service is already registered, it won't register it again. To use that, you need to import this namespace into Program.cs. In the Web API controller, you store private read-only instances of them. You inject them in the constructor's parameter by using the from key services attribute, specifying the key and then the type and the name for it. And then we can start using it in this method, which we're demonstrating here. This outputs our computer types and also the home and kitchen types. So that's it set up with keyed services. Keyed services makes your code more readable when you want to add multiple implementations of the same service. And we mentioned extension methods like the getRequiredKeyed service, which you can use to inject keyed services into your application. Watch this video to learn more about that. And if you want to download the code example for this tutorial, you can go to roundthecode.com/examples. There's also a link for it in the YouTube video description. Leave any comments that you have about keyed services, and I'll see you on the next video.